week 12, lesson number 2, and today we start delving into probability, and we're also going to do a lot of work with statistics in week number 13 and some work with statistics in week number 14. So without any further ado, let's look at our agenda. Homework answers, do it, of course. Today's lesson will be a little bit short. You actually had the 2 assignments last week, but we're also going to get into the probability and so on. So we're not going to be as long as usual today. All right, first part of the homework answers. And the second. And you know the drill with any issues. Just reach out to me and I'll help you out. All right, here's today's do it. Okay, so I label everything, and it says here points A and B are on opposite sides of the Grand Canyon. So the Grand Canyon's kind of running through here. Here's points A and B. Point C is 200 yards from A, and angle B measures 87, while angle C measures 67. What's the distance between A and B? Well, if we look here, we have angle, angle, side. And the only way that we use law of cosines is if we have side, angle, side, SAS, or side, 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 SSS. This is AAS, so we go law of sines. The sine of 87 is to 200 as the sine of 67 will be to x. So the sine of 87, and always the opposite side, 200. Sine of 67, opposite side, x. Cross multiply. Oh, first find the values. So we put the values in there. Cross multiply. 0.9986x equals 184.1 and divide. And we get 184.4. And that is the distance for AB. Praxis power. Now, there's a lot of probability and statistics on the Praxis test, and we're going to review a little bit of what we've done and then segue into some more practice at the end of the lesson to show you how they ask questions about probability. So let's go. This is like the one we did last week. Okay, so if you work 39 hours a week and you get $9.25 per hour, that's a total of $360.75. But if you get paid $4.25 for the week, $4.25 minus $360.75 is $64.25. No, there's no choice for it. I just wanted to change the number and give you another crack at that question. Okay, let's try this one. Stop and start. You know the drill. Okay, so what I notice here is that each departure is always 55 minutes before the return. 55 minutes before, except service. But it says in this problem, except for a service break, all the trams take the same amount of time between departure and return. What's the missing start time for the C line? So it had to be 55 minutes before 9:30. 55 minutes before 9:30 leaves us at 8:35. Okay, now a little reminder of some statistics work, a little harbinger of the future. Go ahead, give it a shot. Okay, so mean, median, mode. Mean is the arithmetic average. Median is the one in the middle, and the mode is the most frequent or the most popular. So, what's the most frequent or popular number up there? It's 24. There's 3 of those. Therefore, the mode is 24. All right, so what are we going to do now? We're not going to spend a lot of time reviewing the work from the last few days because we have done a lot of that. And the last session was mostly that. Today, we're going to deal with basic probability. So, what does probability say? Probability is, it's a fraction. And the highest probability you can ever have is 1. The lowest is 0. Probability is the number of favorable outcomes over the total number of outcomes, or the number of ways to succeed over the total possible outcomes. So for instance, if we look at this little bag here, in the bag are 7 red marbles and 5 blue marbles. So what's the probability of picking a red? Well, success is defined, or favorable is defined as getting a red. There's 7 of those out of 12 total. So we would say that in simple probability, the probability of red is 7/12. For the probability of blue, well, there's 5 of those, so it would be 5/12. It's always how many there are for what you're looking for. For blue, there were 5. For red, there was 7. Out of the total number of marbles or gumdrops or whatever they're talking about. In this case, the total number is 12. Okay. Basic probability. So there's some dice, and we know on a die, dice is 2 die. On a die, there are 6 sides, numbered 1, 2, 3, 4, 5, and 6. So we're going to learn or do some basic probabilities with die and other things as well to begin to understand probabilities. Like, for instance, if I said, what's the probability that if I roll a fair die, it's not weighted or anything, what's the probability that I get a 5? Well, how many sides of the die are 5? 1. And how many sides are there altogether? 6. So we would say it was 1/6. Speaking of die, what we're going to do is ask you for each probability one at a time. I know that usually we give you stop and start for the whole page, but that doesn't work best with probability because it's much more verbal than anything else. Here's a die. What's the probability of rolling a 3? Well, how many sides have a 3 on it? 1. How many sides are there altogether? 6. So it's 1/6. What about probability of rolling a number more than 4? Well, there are 2 numbers more than 4, 5 and 6. So that's 2 out of 6, which if you wanted to reduce it, reduces to 1/3. Often in probability, we don't reduce. But if asked to, we would know to go to 1/3. What about the probability of rolling less than a 5? Well, there are 4 numbers less than 5, 1, 2, 3, and 4. So it's 4 out of 6. What about the probability of rolling an even number? Well, there are 3 even numbers on a die, 2, 4, and 6. So it's 3 out of 6, which of course reduces to a half. And before the 4, 6 reduced to 2/3. What's the probability of rolling an odd? Well, how many numbers on the die are odd? 1, 3, and 5. So that would be 3 out of 6, which again reduces to a half. What about the probability of rolling a prime number? We began early this year talking about prime numbers. Do you remember what a prime number is? It's a number that can only be made through multiplication by 1 and itself. Its only factors are 1 and itself. But remember, it's in the box up there. 1 is not a prime number. So what's the probability of rolling a prime? Well, we said 1 is not prime. 2 is. 3 is. 4 is not because you could do 2 times 2. 5 is. That makes 3 of them so far. 2, 3, and 5. 6 is not because you could do 2 times 3. So that gives you 3 out of 6 or a half. What's the probability of rolling a 3 or a 6? Well, that would be 2 out of 6 or a third because one side is 3 and one side is 6. So altogether you get 2. Whenever you see the word in probability, it always means to add. So if there's 1, 3 and 1, 6, you add them up to get 2. All right, what's the probability of rolling an even prime number? Interesting question. Well, there is only one even prime number in our number system, and that is 2. So it's 1 out of 6. Notice, not 2 out of 6. There's only one number. That number happens to be 2. So 1 out of 6 is the answer. All right, let's go to this guy. Now, this one we'll do stop and start on, and we'll go through each of the answers when you're done. I'll give you about 5 seconds to get your work done. Oh, well, no, I'm sorry. You have as long as you want. 5 seconds on my end before I start showing you answers because you are doing stop and start. Okay. If you pick a piece of candy out of the box, which flavor would have the highest probability of selecting? So let's just see how many there are in the box, okay? There's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15 altogether in the box. And there's more cherries than anything else. So cherry is the most likely flavor. What's the probability of picking a grape piece? Now remember, probability is the number of ways to do what you're looking to do, favorable outcomes, out of the total possibilities. And we already said total possibilities was 15. How many of them are grape? 4. So that's 4/15, or 4 out of 15. We would normally write our answers as a fraction, 4/15. All right, you pick a piece at random. What do you be more likely to select, lemon or cherry? Well, that would be cherry because there's more of those. How many total pieces of candy? We already said that, 15. Your friend wants either a cherry piece or a grape piece. If you pick the piece out randomly, which one would you have the highest probability of selecting? Cherry, because there's more of those. If you ate 4 lemon pieces, 5 cherry pieces, and 3 grape pieces, which flavor would you have the highest probability of selecting? So this is a little tricky. You ate 4 of the lemons, so there's only 1 left. You ate 5 of the cherries, so there's only 1 left. And you ate 3 of the grapes, so there's only 1 left. So there would be no one with the highest. They're all the same. No, they're all the same. I don't know why that says lemon. It should say that they're all the same. There's 1 of each left, so they're all 1 out of 3. What is the probability of selecting either a cherry piece or a grape piece? Well, cherry or grape, there would be 2, 4, 5, 6 cherries, 7, 8, 9, 10 grapes. So that would be 10 out of 15. Number 8, what's the probability of selecting a lemon? There's 5 of those, so 5 out of 15. Which flavor has the lowest probability of being selected? That would be grape because there's the least of those. It's 4 out of 15. And what's the probability of selecting a cherry piece? 6 out of 15. And then these answers, this whole sheet was actually done by a company. And you'll notice they didn't reduce the fractions. It's often the case in probability that we don't reduce fractions, but sometimes we do. Okay, try this one. The whole page, obviously. Okay. So there's 23 total candies. I wrote that on the side there so you would know and you wouldn't have to count them up again. Probability of orange, well, there's 5 of those, so it's 5/23. And there's your fraction look, which is traditional. What's the probability of picking a yellow? Well, all you got to do is count the yellows because that's your favorable outcome. 1, 2, 3, 4, 5, 6, 7 out of 23. What about blue? Oh, lots of blues. 6, 7, 8 out of 23. Oh, there's 9. 2, 4, 6, 7, 8, 9. Yep, 9 out of 23. What's the probability of picking a green? Well, there's 2 of those. 2 out of 23. Which candy is least likely to be picked at random? Definitely green. What's the probability of picking either a yellow candy or a green candy? Yellow or green. So we said that there were 7 yellows and 2 greens. So or means add them. 7 and 2 makes 9. So it's 9 out of 23. What's the probability of picking either orange or blue? Well, that's 2, 4, 5 oranges. And we said 9 blues. So that's 14 out of 23. And would you be more likely to pick orange or yellow? Well, there are more yellows, so it would be yellow. Okay. This is pretty fundamental probability. It's not meant to be hard, but they do ask about these kind of questions on the praxis test, and it's a lead-in to when we get into more involved probability next week. Okay, here we go. Try these 3 questions. Actually, these 4 questions. Go ahead. Okay, the probability of spinning green. So on this one, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 regions. 3 of them are green. So that's 3 favorable outcomes. What you want to do out of 12, 3 out of 12 is 1/4. This time they did reduce. What's the probability of spinning red? Well, let's see if this has 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It does. And there are 5 reds, so it's 5 out of 12. The letters from the word algebra are placed in a bowl. What's the probability of choosing a letter other than A? Well, there's 1, 2, 3, 4, 5 letters that are not A, and there's 7 letters altogether, so that's 5 out of 7. Lastly, find the probability of drawing a 10 from a standard deck of 52 cards. And nowadays, kids don't play cards. Years ago, they did. And when I learned probability, we learned it with dice and cards and dice. But kids don't play as much. Now they play video games. In case you don't know, every single type of card, an ace, a jack, queen, king, 1 through 10, they all have 4 of each. They have a club, a spade, a diamond, and a heart. So, and diamonds and hearts are red, clubs and spades are black. So the probability of drawing a 10, there's 4 of those out of 52 cards. So 4 52nds, which reduces to 1/13. All right. Through 1, 2, 3, 4 more questions for you to do. Go ahead. Okay, so Ricardo has a spinner here, and he also has a bag of marbles. Bag of marbles has 2 red, 3 green, and 3 blue marbles. What's the probability he spins red and picks a marble? Now, this word "and" in probability means to multiply. The word "or" means to add. The word "and" means to multiply. So, red on the spinner is 1 out of 4, and red out of the bag is 2 out of 8. So 1 out of 4 times 2 out of 8, because the word "and" means to multiply, it's 2 over 32, which reduces to 1 over 16. Okay? Number 2, how many outcomes are there when you toss a coin and roll a die? Like we said before, you're going to multiply. So there's 6 outcomes with a coin. 2 outcomes with a coin and 6 outcomes with a dice. So 2 times 6 is 12. What's the probability of picking a blue marble, putting it back in the bag, and then picking a red marble? Well, a blue marble would be 4 out of 7. I put it back in the bag, so there's still 7 in there. And then I want to pick a red marble. There's 3 out of 7 then. So it's 4 out of 7 times 3 out of 7. Okay? Notice it's "and." When you do one then the other, you're picking a blue and a red in that order. Lastly, if you spin 2 times, what's the probability of landing on green? So that's green and green. Green and green would be 1 out of 6 times 1 out of 6, which is 1 out of 36. Try these 2. Okay, spinning a green and rolling a 6. So this particular spinner, I believe, 2, 4, 6, 8, 10, 11, has 11 regions, and green would be 5 out of those 11, and 1 out of 6 for rolling a 6. So 5 11s times 1 6 is 5 over 66. Remember, when I do one "and," there's the key word "and," or "then" is also a way of saying "and" in probability. Then you're going to get to multiply, or add, and, or everything else, multiply. All right, next one, coin and a number cube, that's what they call a die, with the numbers 1 through 6 are tossed. What's the probability of the coin showing tails and the number cube showing 3? So the probability of tails is 1 out of 2, right? Because there's a heads and a tails. Favorable outcomes tail out of 2 possible outcomes. And then the coin would be, number 3 would be one side out of 6. So it's 1/2 times 1/6, which is 1/12. All right, for each of these ones, select the true statements. I believe that there are 2 trues in each list. Just do number 1. We'll go over that together, and then we'll do number 2. Go ahead. Okay, so suppose you buy a bag filled with colored marbles. What you know is that the probability of the bag has at least one pink marble is 0.17. The probability of it has at least one black marble is 0. So the only way a probability can be 0 is if it's impossible. So that means there are no blacks in the bag. And 0.17 might not be a great priority. It might be a pretty low priority, but it means there's at least one pink marble in there. So it is certain that the bag has at least one pink marble. Oh, it does have one pink marble. That's true. I don't know why I didn't mark that. I had that marked and then I moved it. It's unlikely that the bag has at least one pink marble. That's not true. It has to have a pink marble. Otherwise, you couldn't have a probability. It's likely the bag has a pink marble. It's impossible the bag has a pink marble. No, it's certain it does. Otherwise, it wouldn't be 0.17. As far as the black marble goes, it's certain that it has at least one black marble. No, it definitely does not have it. It's impossible. So let me correct this now. That's originally where I had it, and I don't know why it wasn't there. You have to have one, otherwise it wouldn't be 0.17. And it's impossible that it has a black because that probability is 0. Okay, you try number 2 now. Okay, so suppose you have a bag filled with colored marbles. Probability the bag has at least one red marble is 0.72. The probability it has a brown is 1. It is certain that the bag has at least one red marble. Absolutely so, because it's 0.72. I think I also changed that one. It's likely the bag has a red marble. No, it has to. Otherwise, you couldn't get a probability of 0.72. Now, as far as the brown marble goes, it says the probability it has at least one brown marble is 1. So that means the probability has to be that there has to be a brown marble there. Okay. Solve these problems. Now what we're going to do is take the idea of probability and carry it to a bigger example. So let's say that we have a bag of marbles that has 10 marbles in it, and the probability of picking a blue is 1 out of 5. So how many of the marbles in the bag have to be blue? Well, it would be 2, right? Because if it's 1 out of 5 for a blue, and there's 10 total marbles in a bag, then there has to be 2 of them blue, because 2/10 would reduce to 1/5. Or you could say a proportion, 1 is to 5, as how many is to 10. Because 1 out of 5 is the probability, and then 10 is the number in the bag. So try number 1, just number 1. My hard drive's making noise. Okay, so scientists in the Amazon jungle want to find the best estimate for the African lion population. How do they do this? In the Amazon jungle, there are no African lions. There's jaguars, but there are no African lions. So these scientists, somehow with African lions in South America, because the Amazon's in South America, tag and release 20 African lions as part of a research project. Later, they found 160 African lions, 8 of which were tagged. Okay, so there were 8 tagged African lions in the Amazon jungle. How that happened, I don't know. How many African lions do you think there are altogether? So the way to do this is to say, okay, look, 8 out of 160 were tagged, but I tagged 20 altogether. So how many should there be as an estimate? So if it was 8 out of 160 tagged, then since I tagged 20, it would be 20 out of how many? Cross multiply, 8x is 3,200, x is 400. All right. So hopefully on number 2, they don't mistake where an animal lives. Try number 2. Similar question. Okay, Ronald works in an ornithology department. That's where you study birds. The seniors asked him to find out the best estimate for the local bird population. So he tied a belt around the legs of 40 birds. A few days later, he observed 520 different birds, 34 of which had belts. To the nearest whole number, what's the best estimate for the bird population? So 34 out of 520 had belts. And altogether he had tagged 40 birds with belts. So that means 40 would have how many? So if 34 has 520, 40 would have how many? Cross multiply. I get 34x is 20,800. And then when you divide by the 34, you don't get a whole number, but it said rounded to the nearest whole number. So that's 612. Now we're back to praxis power. A little bit of probability work. 2 quick questions on probability that you're likely to see on the praxis exam. Go ahead, give this one a shot. So you're going to get a tails and 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 a tails. So that's 5 times you're going to get tails, and each time is an end. So that is a half times, because the end, a half times. A half times a half times a half times a half times a half is 1 out of 32. Remember, or, add, and, or anything else, multiply. Let's try this one. Directly off an old praxis test for middle school mathematics teachers to be. Okay, sample survey, 500 people showed 200 subjects support team A, 250 team B, and the rest don't support either team. It almost sounds like politics. What proportion of subjects supports team A? So team A is 200 out of 500, and 200 out of 500, remember, favorable team A, 200, total possible outcomes, 500. 200 out of 500 is 0.40. The happy recap, says Bob Murphy. We went over similar figures a while ago, but I just thought I'd mention they have the same shape and the sides are proportional. Sometimes people only say same shape, but you got to remember sides are proportional. You go with little is to big as little is to big. Rectangles, rhombi, and squares are all in the parallelogram family, so they have all the parallelogram properties. That's an old happy recap, and what I had to add to it that I did not, I apologize, but I will verbally state it now, is that probability is the total number of positive outcomes, the things you're looking for, favorable outcomes, over total number of outcomes. So it's favorable over total. And the other thing is, whenever you're doing 2 things or more, if you see the word or, you add. If you see and or anything else,